Hey guys, here's a quick little video to help you with the angle pairs that we talked about in class. If you were in class, you got the definitions and the diagrams that we used in these examples. If you weren't in class and you need a little help finding these, they're all in your book. And if you have any questions on it, you can certainly ask. But I wanted to focus on the examples because that's where we kind of ran out of time. So if you go to the bottom of the first page here, there was an example for using the angle pairs. So they're giving you one angle here. Measure of angle 4 is 168 degrees, and they want us to figure out what angles 3, 5, and 6 would have to be. So have your definitions handy, put them right next to you as you go through, and just look for anything in this picture that kind of gives away where to go. For instance, I'm seeing the 168, and I see how it's kind of next to angles 3 and 6. Well, angles 4 and 3 have a very certain and special relationship, and angles 4 and 6 have a very certain and special relationship. So if I were to just cover up the 5 and the 6 at the moment, what's that look like to you? I mean, hopefully that looks like just a straight line, which translates to a straight angle. And if that's a straight angle, and you've used 168 degrees for this one, well, how much is left over for this one? Well, hopefully you did say 12 because the total is supposed to be 180 for a straight line. So you have 168, you have 12. If I had, instead of covering up 5 and 6, if I covered up, 3 and 5, hopefully you would have seen that angle 6 would also complete this straight angle, and you have the 168 here and then 12 here. All right, so it's a linear pair, right? Again, if you look at your examples, this is a linear pair. It's also a straight angle, so it's got to be 180 degrees, and if you've used up 168, there's only so much left over for the other two. Which leads us to our next connection of, if you look at the ones across from each other, these have a special name as well. If you look at your definitions, you'll see that these are actually your vertical angles, and vertical angles look like they are always the same, and in fact they actually are. So if this is 168, then angle 5 would have to be 168, which you could quickly check because these two also have to add up to 180 the same way as before. All right, so if you have a situation like this where you have two lines intersecting, forming those vertical angles in linear pairs, as long as you know one of them, you can easily get all of them. All right, so that's the first example. Another special pair that we talked about, let me zoom in a little bit here. Another special pair we talked about were complementary angles. Let me just clarify that a little bit. All right, so we have two angles here that are given to us as complementary. If you look in your notes, you'll see that complementary angles must add up to 90 degrees. So angle A and angle B have to add up to 90. Now there's no picture here, but the fact that they told me that this is complementary, I know instantly that these have to add up to 90. No, that doesn't mean this equals 90. And no, that doesn't mean this equals 90. That would basically mean that each of these are right angles, which they are not. That's not given. They're saying angle A and B are complementary, which means the measure of angle A plus the measure of angle B must equal 90 degrees. That's what complementary means. So if A is 11x plus 24 and B is x plus 18, that's got to equal 90. Oop, that's got to equal 90. All right. If you're thinking of setting these two equal to each other, well, at no point did they tell us that A and B are congruent. So you can't assume something like that. The only thing you know is that they're complementary. And at this point, the geometry part's done, and now it's an algebra exercise. So combine like terms since they're on the same side of the equation. 12x plus 42 equals 90, and do your normal, routine for solving for x. So I'll get the 42 out of there. That's 48. It looks like x is, 4? So x is 4. Let's put it back in and check. That would be 44 plus 24, which is 68. This would be 4 plus 18, which is 22. Is 68 plus 22 equal to 90? Yes, it is. We know we did it right. In fact, it did ask us for the measurements, so we had to do that anyway. But it's a good thing to do regardless. All right. By the way, if at any point, obviously, if I go fast and you lose a step or something, feel free to obviously pause and rewind whatever you need to do. And if there's still something that needs clarification, I know I don't always write the algebraic steps all the time, like subtracting 42 from both sides. If that's something you still need help with, just ask and I'll clarify. Okay? All right, so for the next one, they look like we want to find a couple other angle measures. DEG, which is this one where the 6x is, and GEF, which is where the 4x is. And there's no numbers here. However, they do give us this, And we do know that we have a straight line here. Okay, this is a straight line, so it's a straight angle. So that's, again, just like the first example, has to be 180 degrees. I've used up 90 right here, right? That's got to be 90 degrees. That's the symbol for right angle, which means these two angles together have to be the other 90, right? We basically have hiding in here, we have a linear pair of angle DEF and angle DEH. So if this is 90, this is 90, and if this one's 90, DEF, well then this little one plus this little one must add up to 90. You could also do this little one plus this little one plus the 90 equals 180, but in the end, you're still going to end up here at some point, no matter how you look at it. All right? And then at this point, the algebra is harder up there, but this one's not as bad. This one just ends up being x equals 9. Put it back in. That's 36 degrees. Put it back in. That's 54 degrees. 54 plus 36 is 90. All right, so this one you had to recognize that you had the 180 to play with, and you had 90 right here, and the rest kind of falls into place. So technically, without saying it, they gave you a pair of complementary angles, right? They didn't say it, but you had to kind of deduce that from what was given in the picture. Okay? The next one, these are probably the toughest, you know, historically speaking, just because you see an X and a Y, right, and it gets a little confusing. So all I can say is do like what I did on the first example. Cover stuff up, right? If something looks confusing, start covering things up until something jumps out at you. The first thing I notice personally is I look for where are the variables the same, right? Where are the angles that involve just X's? Where are the angles that involve just Y's? I think that makes it easier. If you start matching up things like this, right, the X and the Y, you're going to get a little stuck. If you start matching up this X and this Y, you get a little stuck. It's not that it's wrong. It makes the algebra, excuse me, a lot more complicated. So let's try to find the easiest way first, and if that doesn't work, well, then we'll make it more complicated. But my eyes are drawn to these two. If my eyes are drawn to these two, that means I want to cover up this guy. If I cover up this guy and I look at these two, right, that should look familiar, okay? That should look a little bit familiar because we actually did that on the first example. Remember with the 168? Remember this? And I covered up like here, and we knew that those two added up to 180. Well, check this out. If I cover up the one that involves the Y, and I look at these two angles, right? In fact, if I turn it, what if I do this? Maybe will that make it easier? Right? Look at these two angles. They're adjacent, right? They're right next to each other. They're adjacent. They form the straight line, so they're a linear pair, right? If we put all the pieces together, and if it makes a straight angle, straight line, that's 180 degrees. So this plus this must add up to 180. Okay, that doesn't mean they're each 90. Okay, I know the picture makes it definitely seem like they're not 90, but there's nothing giving me that these are 90. They're just supplementary. So when I set this up, I'm actually going to write 8x plus 26 plus, that's one of them, plus the 3x must be 180. I'm not going to set them equal to each other. I never was given their congruent. I'm not going to set them equal to 90. I don't know that they're right angles. And I'm not going to involve the y yet because right now I just want an equation that has x's in it. Okay, I'll get to the y in a second. So you're not going to be able to solve x and y simultaneously. Do one, then the other. So let's solve this. So I have 8x plus 3x is 11x. 26 I can't combine with anything yet. I'll bring the 26 over. So that's 154. So x has to be, let's see, what's that, 14. Okay, you can, again, pause, rewind, whatever you need. So x is 14. And actually, they just want the values of x and y. But you know what? In order to get y, I kind of need to know what these angles actually are. So I'm going to actually take the 14, plug it back in, figure out these angles, and then go from there. 14 times 3, that's not so bad. What's that, 52? Or 42, sorry, 42. 42 degrees. I plug the 14 in here. 8 times 14 plus 26. That's 80, 32, 112 plus 26 is 138. Let's see if that makes sense. I did that kind of quick. 138, oops, I cut that off. Sorry, 138 plus 42 better add up to 180, and I think it does. I think we're good. Now, here's the fun part. If you've done all this work, you figured out x, you plugged it back in, you know it worked, then getting y is actually easy now. If this is 42, what does this angle have to be? Right? If this is 138, what does this angle have to be? This has to be 138 degrees. So 5y plus 38, 5y plus 38 must equal 138. Okay? Now you could also do 5y plus 38 plus 42 equals 180 if you want to kind of do it the same way we did this one. But if you already know it's 42, let's keep it simple. All right, but that other way would work as well. And now solving for y is no big deal. In fact, the numbers work out really nicely here. Y ends up being 20. Okay? So far, so good, I hope. If you are getting stuck on anything, I sure hope you'll be able to post your questions. But we have one more to do. And this one, a little more complicated on the algebra, but the concept is almost identical to what we've already done. Okay? I'm looking at this. Again, I see x's and y's all over the place, and I need to pick a place to start. I like the fact that I see x's here and here, so I want to try to see if those match up. And I like the fact that I see y's here and here. I want to try to match those up. I don't think I'm going to go with this route for these, right? Because if I do this route, I'm going to have an x and a y in the same equation. That's going to make it harder. Okay, it is still doable, but it's much, much harder. So I think instead, I'm going to cover up either these two or these two and try to match up the x's and the y's. All right, so let's look at the y's first, just because that's what I have right now. So I'm looking at those, and hopefully you recognize those as vertical angles. Okay, those are vertical. I know it's horizontal, but remember the name of it is called vertical angles when you have the ones across from each other like that. So those are vertical angles, and what do we now know about vertical angles? It happened here, it happened here, and the most obvious place probably was here. Vertical angles were both 168 in this example. Vertical angles were both 12 in this example. Vertical angles were both 138 in this example, and if we finish this off, we could have gotten this angle to be 42. So if you didn't notice already, or it hasn't been mentioned yet, the vertical angles are always congruent. They're always the same measure. So these two are going to be the same. I'll put a little mark there. And these two are going to be the same. I'll put a double mark there. And if you didn't see that, again, go back to that first example and watch the video again, and you'll see that that's always going to happen. Right? When you have the linear pairs and they keep matching up, going around, the ones across from each other end up having to be the same. So this time, my equation is going to look a little different. It's not going to be adding two together. It's going to be literally this one is congruent to this one, which means their measures are the same. So 5y plus 5 equals 7y minus 9. And that will get us what y is. And then we're going to do the same thing for the x's, but we'll do it separately. All right, so I'm going to bring the minus 5y to this side. So I'm going to have 5 equals 2y minus 9. I'll add the 9. So 14 equals 2y, so y equals 7. Y equals 7. I could put it back in and check. 49 minus 9 is 40 degrees. 35 plus 5 is 40 degrees. I definitely know I did that one right. All right, the x looks a little more complicated because they kind of threw a little algebraic curveball at us, but it's still solvable. Equals 6x plus 50. Notice again, I'm not adding these up. Although technically at this point, if I know these are 40, I could add these two up to be 180, right? I already know if that's 40, this has to be 140. But I kind of want to do both to make sure I don't mess it up. I could set this one equal to 140. I could set this one equal to 140. But I think this will get us to the same spot, maybe just a little bit quicker. So I got to distribute. So 10x minus 10 equals 6x plus 50. I'm going to subtract 6x from both sides. I'm going to add 10 to both sides. And before you know it, using your algebraic process, you'll get x equals 15. And let's check it. 15 times 6 is 90, plus 50 is 140. 5 times 15 is 75, minus 5 is 70 times 2. Double check in your calculator if you need to, but I think we're in good shape. I know I did the plugging in a little bit quick there. Feel free to pause, plug it in your calculators, and you'll see you'll get the same numbers I got. I'm just looking at the time. I didn't want to take up too much of your time with this video. So every problem is solvable with either using the linear pair, using the vertical angles, complementary. There was sort of some hidden supplementary hiding in here as well whenever you have those linear pairs. But if you have any questions, please don't hesitate to ask, and we'll pick up any of the pieces in class tomorrow. Okay? Take care, have a good night, and I'll talk to you soon. Bye.